have an idea how easy it is to find an oxidation number, you will not have a problem with it. If you have an idea how easy it is to find oxidation number, you will not have, all of you will not have problem in it. Now, there are rules that is given to you to find oxidation numbers. Now, those rules can be intimidating, but if you follow what I'm going to tell you, you will find out that they are just normal, usual rule that every chemistry student should know. Now, we know that in the rule, let me take it gradually, in the rules of oxidation number, number one is that all neutral atoms has the oxidation number of 0. I take it again. All neutral atoms have oxidation number of 0. I take it again. In case you're writing, you can write that down. All neutral atom has oxidation number of 0. For instance, this is sodium. This is aluminum. This is magnesium. This is chlorine. Notice that these are all ground state elements, neutral atoms. They don't have an oxidation charge. Then you know oxidation number in it. You can have some textbook put 0 here, 0 here, 0 here, 0 here. So this means that there is no oxidation number in it. The second rule, rule 2. Rule 2 says that all ionic charge elements, the oxidation number of all ionic charge elements is the oxidation number of their charge. And take it again. The oxidation number of all ionic, monoionic or ionic charge element is the oxidation number of that element. Look at what I mean by that. Sodium has an ionic charge of +1. So the oxidation number of sodium here is +1. Then aluminum has a charge of +3. The oxidation number of aluminum here is +3. Then chlorine has a charge of -. Sulfur has a charge of -2. Oxidation number for sulfur -2. Oxidation number for chlorine -2. At this junction, you understand what the first rule says. All neutral atoms of element has oxidation number of 0. Any charged or ionized or electrically charged atoms of element has the oxidation number same as the oxidation number of that atom of element. And then rule 3 now. Rule 3, I want to take it, all complex ion. The overall charge of a complex ion is their oxidation number. Now let me take it again. Although the individual charge combine to form the overall charge of the complex ion. But I want to take it from the polyatomic ion to the complex ion. Now let's take the third rule, break it into 2. We'll talk about the polyatomic ion and the complex ion. Now in rule 3, let's start with the first one, polyatomic ion. All polyatomic ion has the overall charge, the overall charge of all polyatomic ion is their oxidation number. The overall charge, let's say this. Now, this overall charge is the oxidation number for all this, alright? Because their overall charge represents their oxidation state. Are you now? But meanwhile, the individual element has different oxidation states. And take it again. The individual element has different oxidation states. But for the compound, for the polyatomic ion, all of them together, their overall charge is collectively for all of them. That is collectively for all the atoms of elements involved in that polyatomic combination. Alright? So now we have complex ion. Let's say we have this copper amine, copper 2 tetraamine. Now the overall charge is their oxidation state for all the elements involved in that complex or polyatomic ion. So we go to the next one. The next one we're going to talk about is oxygen. Oxygen has an oxidation number of -2, except in peroxide. Oxygen has, you can write that down. Oxygen has oxidation number of -2, except in peroxide. in oxygen has oxidation number of -2, but in peroxide, the oxidation number is -1. Peroxide like this, like hydrogen peroxide. Alright? The oxidation number of oxygen is -2, but in peroxide it is -1. Now for hydrogen, okay, because of time, hydrogen has an oxidation number of +1 if it is combining with non-metal. Okay? But when hydrogen is negative, it is combining with metals. Hydrogen is positive if it is combining with non-metal. Hydrogen is negative if it is combining with metals. You see that? Hydrogen is standing alone, although it's part of is belonging or grouped as one, but it's standing alone because it can behave like a metal, it can behave like a non-metal. When hydrogen bonds with non-metal, it behaves like metal. When it bonds with metal, it behaves like non-metal. Now let's see some problems, because problems are the most important thing now. Let's solve the problems. Now let's say you are given these elements and you are asked to find the oxidation number for chlorine. What's the oxidation number for chlorine? What you want to do is that what is the oxidation state of potassium? According to the periodic table. The oxidation number of potassium in the periodic table is +1. So you have +1 plus chlorine, which is what you're looking for. We don't know that, so we make that X, and then we have oxygen. Oxygen has 3 elements of oxygen there, and then we're going to multiply -2 times by 3. Everything is equal to 0. Well, I'm forgetting one rule. The rule states that for a compound, the overall charge is 0. For a compound, the overall charge is what? 0. That's the last rule. Add that to the list. For the compound, the overall charge is 0. You can notice that there is no charge here. And this is a compound. It's not a polyatomic ion. It's not a complex ion. It's not a monoatomic ion. It's not all this. This is a compound. There is no charge in it. 0 charge. Now, that's another rule. We should see a compound now. So we have 1 plus x plus -6 is equal to 0. So we have that x. When 6 goes to the other side, it becomes +6. When 1 goes to the other side, it becomes -1. So x is equal to 5. So this is potassium triazochlorate 5. Potassium triazochlorate 5. So let's do another one. Let's do another one. Let's say we have this. Okay, now you are asked to find the oxidation number of chromate. In fact, what's the name of this compound? You can be asked, what is the IUPAC nomenclature of this compound? You have to find the oxidation number of the chromate so you can be able to know the IUPAC nomenclature. Okay, now what's the oxidation number of chromate? That's what we are asked to do. So potassium is 1 and it's 2 of those. 1 times 2. Chromate is 2. X, so it's x times 2. Alright, so let's make it 2x because we're looking for 2 of those. So it's 2x, and then plus oxygen is -2 times by 7. Everything is equal to 0. This is also a compound. Now we have 2 plus 2x plus -14 is equal to 0. So we have 2x is equal to -14 plus to the other side. It becomes +14. 2 plus to the other side, it becomes -2. So we have 2x is equal to 12. 14 minus 2 is 12. We are dividing by 2, divide by 2. X is equal to 6. This is potassium heptaoxodiene is 2, not just chromate. Potassium heptaoxodichromate 6. Potassium heptaoxodichromate 6. You see that? That's how to find that. Let's do another one. Let's do one of the simplest ones now. Carbon dioxide. So why is it called carbon dioxide? Anyway, carbon is x plus oxygen is -2. -2 times by 2 over there is equal to 0. So what we have now is x is equal to 2 times 2 is -4. Cross the minus 4. Let me do it so you can see what I'm doing. X plus minus 4 is equals to 0. Cross the x to the other side, the 4 to the other side, it becomes plus 4. So this is carbon 4 oxide. You can solve as much, as many as possible. Let's solve one more from this one before we leave it. Let's solve one more. This one I just cleaned up the board is one of the questions that is being asked in UTME exam, West African Nigeria. So we have it occurs almost usually. Now let's have H2SO4. Now, before now, while I was still, everyone were all in there, No one become a master of any subject without giving his diligent time to it. You need to know that before you become a master in any subject, before you become skilled, before you become good in any subject, you just need to look away from these things we are doing. Look at the discipline. Discipline is more important than talent. Discipline is more important than talent. You can do it. Everybody can do it. Sit down and take up the notes and take up the classes and you become the best. That's how to do it. Now, this is H2SO4. Before now, I usually think that this is hydrogen tetraoxosulfate. I don't know. Why is this 6? That time, I used to think that it is hydrogen tetraoxosulfate 6 acid. I would say, hey, this is 4 plus 2. 4 plus 2 is what? 6. And I think, yeah, I've got it, yeah, I've got it. No, you have not got it. You just say, those days, I would say hydrogen tetraoxosulfate 6. Why is this tetrasulfate 6? I would say 4 plus 2, 6. It's not like that. We have all been there. I've been there. Maybe you are there. Just look up at me. Look up now. So we have, this is hydrogen is 1. And hydrogen is oxidation number of 1. So I have 1 times by 2. Because of 2 of those. Sulfur is X. We don't know that. Oxygen is minus 2 times by 4. Everything is equal to 0. So we have 2 plus by X plus by minus 2 times 4 is minus 8 is equal to 0. So we have X. 8 goes to the other side becomes plus 8. 2 goes to the other side becomes minus 2. So X is 6. So that is why it's called hydrogen tetraoxosulfate 6 acid. So let's go to another one. Let's look at some polyatomic questions, polyatomic ions question. Let's look at this map. What's the oxidation number for magnesium? Okay, we don't know that. Magnesium is X. We don't know that. So we know that oxygen is minus 2. Minus 2 times by 4 is equal to the overall charge. You see, the overall charge is the combination of all the charges that combine together to form the polyatomic ion. Please, polyatomic ion. There's a video on that. Polyatomic ion, complex ions. Don't call polyatomic ion complex ion. Don't call polyatomic ion compound. Before now, sometimes before now, I say this is not a compound. This is a polyatomic ion. Anyway, we have a video of that. So we have magnesium is X. So we have X plus this is minus 8 is equal to 0. So when 8 moves to the other side, it becomes plus 8. But remember that we have a minus sign, not 0, minus sign. You see that? Don't forget that. Then minus 1. Okay? X is equal to 7. So this is tetraoxomagnet 7. Tetraoxomagnet 7. Let's do another one. Let's do another one. Let's say we have K, M, NO minus. Just this. So we have this 1 potassium is there. We know that. Magnesium, we don't know that. So we put X plus oxygen is minus 2 times by 4 is equals to minus 1. So this is 1 plus X plus minus 2 times 4 is minus 8. And then we're moving minus 8 to the other side. X is equals to 8. And 1 comes there. Minus 1. Remember there's still a minus sign. Minus 1. So this X is equals to 6. So this is potassium tetraoxomagnet 6. But meanwhile, you can find this one. Common sense. There is no charge here. This should be potassium tetraoxomagnet 7. You want us to try it? Let's try it. Let's try it. Because if you just take away one from here, you will get the answer. But I want you to know that these things are very, very easy. Very easy. This is 1. 1 plus x, we don't know that, plus minus 2 times by 4 is equals to 0. So this is 1 plus x, minus 2 times 4 is minus 8. Remember to put your plus is equals to 0. This is x, 8 move to the other side, plus 8, 1 move to the other side, 1. So x is equals to 7. Potassium tetraoxo magnate 7. So let's do more, let's do more. No. Let's do more. Let's do more. Let's say you are given this. Let's look for another polyatomic element. CO, no, let's do this. HNO3 minus. Alright, now, next in line, we need to do more for a complex ion. Okay, this is polyatomic. Let's go for complex 2. So we have this. What is the oxidation number of nitrogen in this compound? So I have 1 plus x, I don't know that, plus oxygen is 3 minus 2. Remember, oxygen is minus 2. And I find out something about oxidation number questions. Is oxygen is always appearing there. Usually appearing. Oxygen is usually appearing. That's the secret. And it's minus 2. Except for peroxide. Okay? And hydrogen is always appearing. If it's bonding to metal, it is going to, if hydrogen is bonding to metal, it will have a negative charge. Minus 1 charge. If it's bonding to non-metal, it will have a positive charge. Okay? Plus 1 charge. Right. This is minus 2 times by 3 is equals to, there's a minus sign here. And then we have 1 plus by minus 6 is equals to minus sign here. So, look at my x. 1 plus x, don't forget that. So I have that x is equals to 6 to the other side. It becomes plus 6 minus 1. 1 to the other side minus 1. So x is equals to 4. Alright? So this is hydrogen triazonitrate 4. Now let's do complex, more complex ion, and then we call it a day. For the complex ion, let's go for copper 2 tetraamide. This is copper. So, why is it called copper 2 tetraamide? What's the oxidation number for copper? That's what you're looking for. Make it x, x plus. Now, nitrogen and hydrogen has these 3 subscripts. No, now it is now, nitrogen is minus 1, in the, minus 3 in the periodic table. Nitrogen is minus, it belongs to be 5. 5 minus 8 is minus 3. So, minus 3 times by 4 plus, that's for nitrogen. For hydrogen, is plus 1. And it's plus 1 times by this is plus 3 times by 4, and then we have everything is equal to plus 2. Very, very simple. This will give you minus 12. This will give you plus 12 is equals to 2. This will cancel out this. And then we have that x is equals to plus 2. So this is why it's called copper 2 tetraamide. Alright? So this is blue in nature. It's a blue copper 2 tetraamide, deep blue in nature. So this is all we've got for you. But we have an assignment for you. What's the name of this? What is the oxidation number? What's the oxidation number of iron in that compound? Maybe you didn't see that. Let me write it here over there. Over here. Don't know. What's the oxidation number for copper? Alright, find this also. Okay. What's the oxidation number for sulfur? What's the oxidation number for sulfur? Now, this is all we've got for you. If you have a question on the oxidation number, you can drop the question for us, but we're going to attend to it. I want to try to bring up more questions before we call it a day. What's the oxidation number for sulfur here? Alright? Let me show you another one. Let's do another one. The one we have not done before. Okay. What's the oxidation number for chromium? For chromium, the underlying one. For sulfur, for iron. So this is all we've got for you. Thank you very much for watching. See you soon.